I now want to take a couple minutes to look at the correct way to simplify a fraction, because it is done incorrectly on such a regular basis. I just want to point out the right way to do it. If we were to look at a fraction like 15/25, we're going to start off with this numerical example just to establish a pattern for the correct way to do things. You look at your fraction, like in this case 15/25, and what you want to look for is factors. A fraction is always simplified by canceling out factors. For example, the 15 has factors of 1, 3, 5, and 15 itself. 25 has factors of 1, 5, and 25 itself. When you reduce a fraction, you always want to look for factors that both the numerator and the denominator have in common. Now, of course, 1 is always going to be common to both numerator and denominator, but that is really of no assistance when you go to simplify. In this case, it's going to be the 5 that we want to make use of. So we would come over to the fraction and divide both the top and the bottom by the same factor. And by doing that, the fraction would be reduced. Alright, so if we were to look at another example, let's say we had a 9/27. We see that both the numerator and the denominator can be divided by, let's say 3. So we'll do that, dividing both top and bottom by the same factor. We get a 3/9 out of this. Now, looking at this one closely, we notice that there was actually a factor a little bit larger than 3 that we could have used. We could have used the 9 to divide both top and bottom. Well, if you happen to miss the larger factor and end up using a smaller one, you can actually go back, repeat the process if you have another factor that will come out, and in a second step get your fraction reduced. Now, when variables start showing up within the problem, they are actually usually easier to deal with than the constants. If I had a negative 14a over a 21a, we can see that obviously the 14 and the 21 have a 7 in common. That is a common factor that we can take out. But we also have this a. And since we're assuming that a is not 0, therefore we're not dividing by 0, we can simply say, well, a cancels out a. Then we can divide out the 7, dealing with the constants separately, and our fraction is therefore reduced. And so we see that the variables, again, are a little bit easier to deal with. If we had a 39abx over a 13ax, we could say x cancels x, a cancels a, the b won't cancel. Then when you divide both top and bottom by the 13, we find there's nothing left on the bottom, and we have a 3b left on top, so we can write that without a denominator, because you do not have to write down that denominator of 1. You can just leave it with the 3b, and that'll be sufficient. Now, a mistake is commonly made if you have an expression like 3x plus 4 over 4. People tend to look at this and think that the 4 is a common factor and they'll try and cancel it out. And that is, in fact, not the way that it can be done. The 4 can't be canceled out because it's not a factor in the numerator. In other words, the 4 doesn't factor out of or won't divide out of the entire numerator. To work this problem, that's what you can actually do, is take the fraction and break it into two smaller fractions, both with the common denominator. portions will not be simplifiable, others will be. So you're basically going to simplify what you can and leave behind anything that you can't simplify. Just leave it in that unsimplified form, or that already simplified form. So to see this again, if we had, say, an AB minus an AC all over A, again, we can break it apart. Both smaller fractions getting the common denominator. Simplify the fractions individually and express our simplified answer. So there's the basics on how to simplify a fraction. When we get into rational expressions later on, you'll see the more complicated forms, but that is the simplest aspects as far as simplifying our most basic fractions.